My name is Natrinder Rajes, and I'll be taking through the career guidance chatbot. So here, this is the career page was basically made for students to help them counsel them on what courses to do, leading them to their given career path. So looking at a demonstration of our application, we're looking at a student who actually wants to become a lawyer and is trying to inquire what course to do and which university. So basically, here when it tells you, when it prompts the chat and tells you want to become a lawyer, the chat will advise him on which course to do and which university major to look for. So it will tell him to do a bachelor's of law, and I will tell him that it can be done at Makerere, which is in Kampala. So in telling him this, you can also help him in making his final decision, and he'll be confident enough in knowing that this decision will lead him to his what? To his career path. So moving on forward, we are seeing that this is a system that is going to be helpful to the students in their choices of courses and in their to boost their academic performance. That it's very useful for the students. And why is AI important here? AI is going to be important here because they're using it in training. The training that we're using it to train the computer science that when a user comes with him with a given course or given career, it's able to help the user and show him the path he can use and which course is able to be using. So here we are using knowledge graphs and large language models, and with this we train a given model debating on a given knowledge graph and it's able to provide a given output. So what is the measurable impact here? That we're seeing students going to be boosted with much confidence in what course they can be able to use, and they will be able to gain academic skills which will be leading them towards their job markets and market and their career goals. So here we're looking at the users, which are our primary users are being high school students who are trying to enroll into the university, and it will be able to guide them on what degree to partake that will lead them their career guide. Then you're also looking at undergraduates who are also looking to upgrade and to advise them on what masters to undertake. So it can also be used by university admission department in helping guide those children who they given courses which they may not actually have information about, then also high school counselors and academic advisors. So we are looking at our ecosystem as having data suppliers, which we are major relying on Uganda University PDFs. Then our API consumers as EdTech platform integrating the tool. Algorithm designers, which are being as algorithm designer, then the governance entities that are clearly following the National Data Protection Authority rule, then and looking at the ethics which are also governing universities from the University Ethics Review Board. So in our data sources and values that we're looking at the data sets, which is actually was created by us and it was scrapped from PDFs and other course-related university resources. And here we came up with the university ID, program ID, career path, skills, working activities, cutoff, and local locations and contacts and other information. So this PDF is a PDF primarily containing Ugandan universities, majorly public. Then also have an on-it which mentioned which has a data set which was having skills describing for every given course which was being done. So a processing pipeline. So in the pipeline, looking at data collection, then data cleaning and structuring, then creating knowledge graphs. Then we embedded this in a set of transformers, then able to come up with a generally working system. So, so ethics and legal framework here are compliance with the Ugandan Data Protection Act. So what is the solution here and what is the AI system description? So here is a look at we're building a model whereby a user is able to query it with a question and is able to generate an appropriate answer that will help guide the student. So here we're able to use LLMs such as Llama 3 and Flanty 5, and we try to integrate them with different retrievers and see their performance, such as Krag, Kag, Sierra, and then VPrag. So here we're able to see its performance as here a user inputs a question, and an output conversation response that is directly informed by the retrieval graph data, including recommendation courses, career path, and other justification. So on that picture of our model that we're using knowledge graphs, which were passed to the LLMs and retrievers and able to some commit and come up with suitable data that's supposed to be used by the users. So externally data, the presence of the knowledge graphs allows the justification of each career guidance recommendation based on the user's input. It will build users' trust and mitigation bias. So this is actually a web application with With a chatbot, as we had seen from the demo. So the key metrics that really are the technical metrics. The average response is usually up to 1.5 seconds. Then when you're using the user-centric metrics, that you're able to see that here, when I increase the user's confidence in what course to take, that what now will be confirmed that okay, this course is able to lead him to a given career path. In the effective metric, this is transparent and transparent reasoning. Like every suggestion shows that the graph linked justification. So the business metrics, we're looking at partnership adoption. The objective is with different people and see how to grow a given project. So here, what is the fair advantage of this? That the fair advantage of our product is that our product is we are using is built on a knowledge graph whereby and it's specific to Ugandan universities, especially public universities, and making it a unique and powerful, making it unique and powerful. So enhancing this model offers guidance around public universities in Uganda, given during the querying of the knowledge graph, the nodes connect basically to Uganda university criteria and courses. So this is to support a Ugandan child, and it will be because the Ugandan child will not query the university expecting an answer which is not be out, it will be in those given brackets. So the feedback loops are context aware conversation memory improves reasoning with a session. Here, what we're trying to say is that these sessions whereby that when a conversation is held with the bot, this will be able to understand the user and it will be able to memorize the conversation and to be able, like, to be topping up on the given conversation. So long-term differentiation, explainable recommendations, since a user can trace why a course is recommended and equitable guidance aligned with Ugandan data protection. So moving on to the next. So we're looking at channels and distributions. How we're going to distribute data? We're looking at this system, which is going to be targeting course finders, university sections, and career guidance tools. So we're looking at deploying most of these systems, advocating it in schools and to users, and also integrating it, trying to integrate it on the application portals so that users may get to know about it and be able to use it. So this is going to be delivered in such a way that it's going to be an web application, a chatbot interface, and an API integration for universities. So here I'm seeking partnerships with live demonstrations that EDH take conferences, then trying to put it in hackathons, then contextual marketing through partnerships with university ambassadors. So the revenue streams that here in the direct revenue model, universities and schools pay subscription fee for nutrition access and how to use the model for further career guidance from. Then indirect revenue insights from anonymous trends can be packaged to support research institution, government agency, and skill development. Then the free like students are able to access basic courses and university recommendations for free. So premium analytics unlock labor market and forecast and career planning. So one of the key resources here, the human resources, the team containing AI engineers for modeling, deployment, and Unix designers for user facing an application. So in the technical infrastructures, we use face vector storage for efficient similar search, then network X for the knowledge graphs, then transformer embeddings for the language understanding, then Grok API to provide the LLM such as NAMA, then the data infrastructures employees here we're employing APIs for data access, then annotation tools and labeling teams for training data. So here organization resources, we're leveraging research partnerships for innovation, continuing the channel. So final resource, we are seeding funds, then grants, venture capital, then strategic partnerships. So in the modeling, the life cycle activities that we are seeing data acquisition, then graph building, and using files, and testing it, and then deploying the system. So product deployment activities, we're looking at feature engineering, then you're using UX design, then an API development, testing and integration. So operation activities, we are monitoring the model drift, then maintaining the data pipeline, ensuring uptime and secure. So this is to keep the system working normally without any errors or complications. Then we are conducting ethical adults so that the system is actually not biased about anything, so that users get reliable answers. Then consumer focused activities, then technical support, training users on how to use the application and others. So here, our key partnerships are we are seeing we used to using Grok, Hanging Face, and cloud providers. Then for data partners, we are actually relying more on universities, public universities. Then ethically, we're looking at market ethic committees, then distribution of partner, looking at media platforms, i.e. Campus B, then strategic collaborators, we're looking at the ministry, to collaborate with Ministry of Education and Sports to get more information. So here in the cost of the data extraction at data collection, so as if actually we're trying to enlarge more about data collection and cleaning it and making it more broad, making it more advanced for expression. It will still come to some fee, yeah, which will be involved in research. Then you're looking at computer and infrastructure cost, whereby having cloud storage, then fast ending and API calls, which are also costly. Then human resource, the engineering, the UI, then the compliance. Then you're also looking at data protection, the license, making the data which is being collected, then the intellectual property registration. Then come to the community outreach for marketing and distribution of the content, customer acquisition events, try to market the application to be used. Then the maintenance try to make sure that the app is actually operating normal circumstances and does not actually break down. So this all cost may actually tend to be more costly and may actually take up to like 200 million, something like that, that we're able to manifest and enlarge this product for massive production and use. So in governance, ethics, and compliance, that's our governance model that we're here we're seeing an oversight from an internal AI ethics review board targeting policies and technically feasible for user impact. Trying to enable everyone so that it can be able to access it and be able to use it. Then fairness should be actually very fair at all learners that way. So here we use Fairlearn to run simulation to ensure that course recommendations are suggested equally across different user profile, whereby depending on every user, our system won't be biased against anyone. So the transparency mechanism that here using system starting, that's the knowledge graph and the data used to build the knowledge graph, it will be clarified and recommended, and here again it can be able to access it. And then like label tool, the system provides justification for recommendation according to the subgraph generated from the knowledge graph, then the legal and ethical frameworks. They're using the PDPA compliance by making the system able to anonymous misuse of chat history after giving amount of time. That if a chat is not given, it can just be easily dropped. You get it? So this system can be improved to have a flag recommendation feature that allows users to report or suggest final irrelevance, whereby a user is able to give feedback on how the system is actually operating. So here in scalability and sustainability, our using scalability framework, our user interface runs on Docker containers, ensuring that the system remains fast even if there is surge in users. And it is actually continuous running, such as when retraining, retraining the graph embeddings whenever new university courses are released, so that we actually enlarge our data sets. Then localization, then here we plan to tailor the system to include specific data from NCHE to recommend career suggestions with sectors identifying a higher growth in Uganda and NDP. So here the financial sector that we're looking at the reinvestments directly, like for example, grow up APIs applying for grants and funds so that we can keep on broadening. Not even such time we shall reach a point whereby even a private university is actually inclusive. Then after environmental responsibility, our architecture first performs compute retrieval from the knowledge graph and large language model. It's only used for final ethics, reducing our overall computing time compared to the purely generative approach, thus lowering the carbon footprint. So here in the resilience, they're planning to deploy our system across multiple clouds available, such as the primary knowledge graph that I said fairly, then the traffic automatic to live replicate. It's the large language API that is down. We plan to have a fallback mechanism to provide basic guidance, ensuring service continuity. So here in the we're looking at our innovation lies a bridge and gap between simple student questions and complex institution data. But here we are looking at, we are using large language models, also using knowledge graphs and personalized education, and we are trying to create an AI whereby it won't only advise the user on what course to take, but it will also show it which given path it can easily be able to take. So here, our trade secret, our knowledge graph is a proprietary data asset containing programs and their relationship with the career skill data that generated the KG. The knowledge graph was made from unstructured university PDFs, and only, and then this is to be copyrighted for more reasons. So it is protected as a trade secret, accessible only via the secure API. So here the paintable process, our method of combining semantic vector search with any line graph transport to generate context for the LLM is unique processing. This algorithm, which turns a simple query into a subgraph into which is eligible for, was actually trying to use it with the retriever such as VGraph, which is able to. So our copyrighted is normally including the code base, including the Python scripts for the data scraping, the back end, and the front end user interface is protected by a copyright. So this is my team I worked with, Shukuko, Layo, and Nelson. So thank you.